Hey guys, EclipseCon 2021. Hope you're all doing well. My name is Marcus Karg. You can read it below here. And I'm one of the co-authors of the JAX-RS specification and API. And in the next 30 minutes, I will give you a short introduction into the new features of JAX-RS 3.1. And because we have scarce time, let's dive right into some code. So, Sarah, if you could share my screen, please, then we go in code. Thank you, Sarah. So, before we start, actually, I wanted to tell you if you have any questions about JAX-RS, please visit my Twitter channel or my YouTube channel. There are videos about JAX-RS, and you will find answers for everything that has to do with JAX-RS, when it will be out, what the new features are, and so on. So, first feature, let's go dive in here. This is, by the way, the greatest features of JAX-RS actually, but it is not something we have done. The Jakarta committee told us that they will ask all the vendors to support Java 11. So what we will do in JAX-RS 3.1 is that we support Java 11. And this is really nice because you can do things like, for example, this pattern matching, for instance, of which makes writing filters much easier because you can get rid of casting, for example, which is often a problem in JAX-RS filters, or you can write better readable code because you have here this var keyword. Oh, I just noticed that if I double click on my screen, then it will enlarge. So you have the var keyword here. You don't need casting here. You have no intermediate custom types. So it's much more readable JAX-RS filters. So as I said, this is nothing that we have done, but it's really great to write JAX-RS code in modern Java. And now you can do that on all supporting application servers. And let's go right into the next feature, which is, let me see, yeah, the multi-part support. This is something really, really cool because many people have asked for that. They want to send multiple files in a single request, and this was problematic before. So you could before JAX-RS a zip file, for example, with multiple files in it, but then the client has to unzip it. With multi-part support, you have support for the special type in that is given already in the forms specification of HTTP, and you can then pack multiple files into one request or one response rather easily with a new API that we have programmed. And that there's an API for client and for server, certainly. So let's switch into the client code here. And you can see that while it looks a bit scary, actually, it's really, really easy. You just tell the client API that you want to have the multi-part form data media type in your response and do a normal post, and you get back actually data that is separatable. And the separation actually, sorry, I need to scroll down. The separation actually can be done with typical simple Java code. So you can see here, for example, that we say we want to have all the parts that we received. So a part more or less is a file, right? Plus its own media type. And we want all of them in a stream. And we get the part here, and then we can tell the part we want to have the content, which is an input stream. And from that input stream, we copy the file into an actual file on the disk. So this is very quick overfly of this feature. You can do a lot of more things. What I want to tell you is just that it's there. We can support multi-form sending and receiving client and server side, and it's really easy if you know JAX-RS. This is a small addition that gives you great power for big responses with lots of PDFs in it, for example. So there's this example is included, by the way, in our examples folder. And you can have all that code when you download it from GitHub. So just go on GitHub, search for JAX-RS, and you have all that examples, and you can look how it's done and all that. So this makes entering the new API really easy. So let's go to the next one. So while this is great, actually, there is one that I love even more. And this is, which example do I show? I show you this example here. Normally, JAX-RS is known for writing applications on the server side. So you have an application server normally, like, for example, Payara, Glassfish, or something like that. And what you write to run on that server is just a resource or a filter or something like that. Meanwhile, a lot of people want to write smaller type of applications, like, for example, microservices. So you don't want to pack a full-blown Payara application server into each of your microservices. And what you actually want is to use Java SE, pure Java SE and a few libraries, and that should be it. And this was possible with some products out there already. There are big frameworks that can do that. And there are smaller products that can do that. For example, you can run a Jersey directly from Java SE since long time. But when you do that, typically you bind to a special vendor-specific API, like, for example, a Spring API, or for example, a Jersey API. And by doing that, you cannot switch over to other implementations. And this might be, well, not nice. When the login is never nice. So with the JAX-RS 3.1 release, we finally came up with an API that allows you to write pure Java SE implementations for microservices that can run all the JAX-RS features, that can run CDI, that can run JSON binding, that can run JAX-B if you still need XML, for example. And you do not have to use any special framework, any vendor-specific API. You do it in pure Java, and a standardized API, pure JAX-RS API. So let me just scroll quickly to the start. So you see here the imports. This is an actual application. And as you can see, there are only Java and Jakarta imports. So there's nothing specific to, let's say, Spring or Jersey or something like that. This is pure JAX-RS. And what it does is, well, it looks scary, but it is simple. Here you can see the SE Bootstrap start method, which more or less does all the work of starting up a JAX-RS container. And here is an application. This is a JAX-RS application, and that's it, more or less. Ignore all the rest. So the question is, how is the HTTP server configured, and how is that run? Well, actually, each implementation of JAX-RS can decide what HTTP server implementation they will bring with. So in this example, for example, I'm using Jersey as the implementation. You don't see that. It's just on the class path. And Jersey will bring an HTTP server with it. It's even is configurable. And you can then tell JAX-RS to start whatever your implementation brings with it. On top of that, start the Hello World class. And then when it is started, you can say then accept. So what does this do? Then accept allows you to get the started instance. So this is actually, well, kind of your application in the running HTTP server. So you have a handle to it. And with that handle, you can do several things. For example, let's look into this code first. You could ask the instance to get the actual configuration. For example, because you want to know on what HTTP port you are running, unless you have configured it, maybe you ask for automatically find a free port. And you can build a base URI out of that. So you have an absolute URI to the application run into this small HTTP server. This is quite nice because so you can print it on screen, for example, so you know what is the base URI that your clients will connect to. What you also can do with the instance, you can say stop on shutdown, which means when your, well, Docker container or Kubernetes instance decides to stop this virtual machine, then automatically the HTTP server will shut down your application gracefully and provides the result of the stopping action. And you can also use that, for example, to find out what was the result of stopping that. Did that work fine or did something crash, for example? In case you like to know the native content, so the actual class that was provided by Jersey, for example, you can even unwrap it. So if you know what implementation you have, you can get access to that too. So I know this was very, very quick. And certainly, this is not a full tutorial today. I just want to get you a short presentation of this new feature. And what's so great about this feature is you don't need an application server. You can just run this. So how fast is that? If you compare it, for example, with Payara starting up JAX-RS and all that, maybe needs several seconds. On the same machine, when you're doing this with Jersey, for example, it starts in 1 second. So you can say, depending on what application server you had before, and depending on what you need to start in your application, it might be 10 times faster, maybe more. So this is really great, and I love this feature most. And if you want to learn about all the APIs that you can do in Java SE with JAX-RS, then go in the new Java docs. You will find all the methods there. You will find a lot of examples there. And just to give you an overview, so all these examples are included, and they all talk about JAX-RS on Java SE. So there's a bit more. For example, if you need HTTPS, for example, you can configure that. So you have a configuration builder. You can give it a protocol like HTTPS, for example. You could even provide an external configuration. It works with configuration from a micro profile, for example. So just look into these examples and you will learn a lot more than what I can show you today. So let's go into the next feature. So by the way, there are so many features I cannot tell all of them today. I have to pick just some. It's just too much for 30 minutes. So for example, what have we done? Yeah, right. Let's go into this. In the past, there were application servers that actually found out what is on the class path dynamically. So typically, you had an annotation called add provider, and the add provider annotation told the application server, please create an instance of this filter, for example, or of that interceptor, and you didn't have to do something programmatically. If you did that on the client, that did not work. And if you did that on Java SE, it did not work too. Also, the support for this feature was limited in one or the other way between the application servers. For example, on some application servers, you could prevent that loading. So what we strived for was to provide an API that will work the same on all application servers. So this will also work the same on Java SE now. And how is this working? Get rid of the add provider. So here you see no more add provider. Just write your feature, your interceptor, your filter, or whatever component you have as a normal Java class, and then do something. Maybe you have heard of the service loader API of Java. So, sorry. What service loaders are doing is that they scan the class path for a file, and the file has a special name. So this is the special name. I hope you can read it. It's a bit small. It's jakarta.ws.rs.core.feature or horror. What a name. So if it finds this file, then it looks inside, and inside it, there is the class name of your feature. So maybe my introduction is a bit quick, but it's actually totally easy. You just need a file, and in the file, you need to name your feature. So what does that? If this file exists, then the implementation like Jersey or like your application server will create an instance of everything that is named in such a file. So you might ask, what is the benefit? Well, I could just still go with provider, or I could go with naming the file in the application itself. Well, yes, you can do that still, but this one is much greater. Imagine the case that you want gzip compression. You could write it on your own, or you could go to a marketplace, and there is gzip compression as a cross-vendor JAX-RS feature on that marketplace, hopefully for free, like open source, or maybe commercial. Just download the jar file that contains this feature, like gzip compression, put it in the class path, and that's it. In that jar file is the magic file that enables the feature, and the implementation, like Jersey or the application server, finds all these features in those jar files on the class path and enable them fully automatically. So if you follow me closely, what I said is you just go to some app store, grab some feature jar file, put it on the class path, and magically you have features. And these features typically are cross-vendor and are cross-application, like gzip compression, as you see it here, or like HTTP cache, for example, or like encryption, or like something like that, or special security features. Everything is imaginable. So to sum up, this is called services in Java. We also call it extensions. And what it essentially does is it opens a marketplace for third-party extensions to your JAX-RS runtime. So not to your application, to your runtime, which you can use with every application server, with every implementation of JAX-RS. And that's pretty great, because things like gzip compression are of common use. And if you write Java SE-based microservices, then you want to have that, but you don't want to pull in a full application server. So just pull that from the marketplace, and you have gzip compression. By the way, if you want to program it on your own, this is how gzip compression feature is, well, at least minimally done. So you can have that from me if you like. So let's check. Yeah, we have 5 more minutes to Q&A. So let's pick one last feature and then we go into the Q&A. As I said, there are many, many more, and I cannot tell you all of them. So just one of them. We are supporting JSON-B like I think several years now, but there is a problem with JSON-B always in JAX-RS. And JSON-B is a special case because JSON-B is needed by virtually everyone today. So there shouldn't be problems with JSON-B. And the problem was like this. When you're using JSON-B in JAX-RS, you had no control over the JSON-B serializers and deserializers unless you modified your entities. But if you cannot modify your entity or you don't like to modify your entity, then you're screwed, right? So normally you would do something like that. You create a JSON-B config and say with serializers and with deserializers, for example, to support polymorphism in JSON-B. New feature, by the way, in JSON-B next release. And then you create a JSON-B instance. But now comes the problem. Your application server ignores the JSON-B instance, so this was good for nothing until you used Jersey or some versions of Jersey. Now, with JAX-RS 3.1, you can do exactly this. This code will configure the JSON-B context. So it will work with all implementations, with all application servers, with all applications. Just put this piece of code, this one, into your application and it will configure your JAX-RS runtime with exactly those serializers and deserializers and adapters that you want to have. So while it's a really small feature, just implement context resolver, it actually solved my problems a lot of time already. So I was told that we have to go into the Q&A and give room for questions of you. And I have seen that there already is a question in the private chat, and I will read it for you. Is it possible to grab the code for Jakarta RESTful Web Services 4.0 now and experiment with the new features? Actually, not for 4.0. I know Andy was talking about 4.0 on Monday, and 4.0 was not yet started already. So 4.0 is just in our mind, and we don't have programmed any features for 4.0. So it's not possible for 4.0, but for 3.1, you can go on GitHub and pull it from there. But the problem is you have no implementation for it. So it makes no sense that I show you where to pick it because you need an implementation. So you need, for example, Jersey or CXF or REST-EC, for example, or any other implementation of JAX-RS 3.1. And they are waiting until the day that JAX-RS 3.1 will be released. And there is the next question which Clark is asking, when will JAX-RS 3.1 be generally available and what compatible implementations are there already? JAX-RS will be generally available by end of October. Well, actually it's done yet, but we are writing on the TCK. So we think it will be end of October until you can download it. And there is actually a compatible implementation, which is Jersey 3.1, which is mostly done, as I have heard, but is not published because they are waiting until the TCK is out so they can really prove that they are compatible. So please just be a bit patient, 2 or 3 weeks, and then you can do your own experiments with it. Are all shown improvements 4.0? The improvements I have shown all are 3.1 actually. And the improvements for 4.0 were covered by Andy on Monday on the community day. And they are mostly around replacing our own dependency injection framework by CDI. So we have 6 more minutes for questions in the Q&A. So if you have any questions, feel free to type in chat and I will be happy to answer them. Until then, maybe I can show you where you can find more information. Just a second. I will open it for you. And then share it on the screen. So this is, oh no, I have to end the sharing first, actually. And then do a new sharing. So you should see now my YouTube channel. So if you have any questions about JAX-RS new features, all the features are explained in videos on this channel. Not now, but upcoming. I'm working on it. So some of the features already are covered and the others will be covered soon.